Hello students, welcome to my YouTube channel ScopeIIT. Today we will discuss about the topic schedule. Okay. Now what do you mean by schedule in Dbms? So schedule basically it is the execution sequence of the transaction. Like we are having the schedule, okay. So for example, my classes are scheduled. Next class I have at 3 o'clock, then 6 o'clock, then 8 o'clock, right? So even like we are having the schedule, same form we are having schedules in transaction. Okay. So what do you mean by schedule? A schedule is an execution sequence of transaction. That means it is the sequence that we have to follow for execution of transaction. So basically a schedule maintains the order of operation in each individual transaction. So what is a schedule in short? You can say it is an arrangement of transaction operation. Okay, it will give you the arrangement that this transaction will be executed at this time. It will tell you the sequence of execution of transaction. Okay. Now, if you will talk about types of schedule, so there are many different types of schedule. One is a serial schedule. What do you mean by serial schedule? All the transaction executed serially one after another. That means you can see here, first of all we have executed transaction T1. Once we have completed the execution of transaction T2, after that only transaction T2 will start. Correct. So here serial schedule means once we have executed transaction T1, after completion of transaction T1 only, transaction T2 will start. So here you can say this is your serial schedule. Again. Next, serial schedule. This is the keyword that you have to remember for Ugcnet, GATE and PGCET, some competitive exams, right? So what is serial schedule? Serial schedule are always consistent. What do you mean by consistent? Consistent, that means if before transaction it was in consistent state, then after transaction also it should be consistent state. So serial schedule should always be in consistent, recoverable, cascadeless and strict. If you don't know these three, these are actually the types of schedule that I am going to cover next. Okay. So I hope you understood serial schedule. Serial schedule means first of all one transaction will be executed. After that only your second transaction will start. Next is non-serial schedule. Non-serial schedule, that means it is possible, like see here, transaction T1 was executed, in the middle transaction T2 has read the value of A. Then again transaction T1 is reading and writing the value of variable B. Then committed, after that transaction T2 will read the value of B and commit. So this is nothing but known as non-serial schedule. Non-serial schedule, that means multiple transactions executed concurrently. They will not follow any specific sequence. Okay, they can execute it concurrently. So definitely in serial schedule it was consistent, recoverable, cascadeless and strict. Okay, so here non-serial schedule will not always consistent, recoverable, cascadeless and strict. Opposite to that. Okay. Next is recoverable schedule. So if in a schedule a transaction performs the dirty read. Now what do you mean by dirty read? Dirty read, that means reading the same data after some period of gap. That is known as dirty read. Okay. So if a transaction performs the dirty read operation from an uncommitted data, that means you are reading the data which is uncommitted. Okay, and its commit operation is delayed till the uncommit transaction either commit or roll back, then such a schedule is known as recoverable schedule. Now what do you mean by recoverable schedule? Recoverable schedule, that means here you can see here in this one you can see transaction T1. So transaction T1, here we are committing the transaction T1. So you can say this is recoverable schedule. Why? Because transaction T1 commits before transaction T2 will make the values changes. Okay. So here transaction T1 is committed, after that only transaction T2 is committed. So you can say it is recoverable. Why? Because we can roll back over here, right? So here this is the example of recoverable schedule. Now recoverable schedule is again of three types. You can say cascading schedule, cascadeless schedule and strict schedule. Now what do you mean by cascading schedule? Cascading schedule, that means one schedule will affect the other schedule. Okay. See here. So if in a schedule there is a failure in one transaction, that causes several other dependent transactions to roll back or abort, then such schedule is known as cascading schedule. As I told you, what is cascading schedule? That means if any problem arises in one transaction, then it will affect the other transaction through rollback, or you can say through abort. Okay. Let us understand with one example. See here, Here transaction T1, that is read a write a, then transaction T2 is reading the same data, then transaction T3 and transaction T4. Okay. Now here you can see transaction T2 is dependent on T1, same transaction T3 is also dependent on T2. Now if any problem arises in transaction T1, then what will happen? This all transaction will get aborted, or you can say this all transaction will get affected. So this is nothing but known as cascading schedule. Now, what is the solution of that one? Just think once, what is the solution of this one? For example, if I write commit after each transaction, so commit, that means your data is permanently saved now. So you cannot roll back. Got it? So if I write everywhere commit, then this problem can be solved. So this is nothing but known as cascadeless schedule. The cascading schedule, that means there is no commit. One transaction will fail, it will make other transaction also fail. Now see, this is your cascadeless schedule. Cascadeless means one transaction will not affect the execution of other transaction. Got it? So see, what is the solution of cascading? Commit. So you can see commit after each transaction. Got it? So this is nothing, cascadeless schedule. Still I'll read the definition. If in a schedule, a transaction is not allowed to read the data item until the last transaction has returned commit or abort. So in cascadeless, the other transaction cannot read the data until your last transaction has committed or aborted the schedule. So this is the example of cascadeless schedule. One more thing, cascadeless schedule allows only committed read operation. However, it allows uncommitted write operation. So uncommitted write operation is allowed in this. Okay. Next is strict schedule. Now what do you mean by strict? Here strict means also like we are strict, no? Similar to that only. See, if in a schedule a transaction is neither allowed to read or write. So that means it's not allowed either to read nor write a data item until the last transaction has returned committed. So what was there in cascadeless schedule? Only committed read operation, but we can do uncommitted write operation. But in strict schedule, we cannot do read or write any operation without commit. First we should commit, then only we can perform either read or write. You can see the example, transaction T1, here they have committed. After that only we can perform read or write in transaction T2. So this is your strict schedule. Okay. Then make a note of this, strict schedule is more strict than cascadeless schedule. All strict schedule are cascadeless schedule. All cascadeless schedule are not strict schedule. Vice versa is not possible over here. Okay. Next is non-recoverable schedule. Okay, that all was recoverable schedule. That means we can recover a data, right? And there are three types of recoverable: cascading, cascadeless, and strict. Next is a non-recoverable schedule. So a schedule where a transaction commit after reading data returned by another transaction that has not yet committed, and the first transaction later fails and need to be rolled back. So if the first transaction fails after the second transaction commit, it becomes impossible to undo the changes made by the second transaction. I'll explain with example. Okay. Now see, here there are two scheduled transaction T1 and T2. In this one you can see transaction T1 is reading the data, transaction T1 is also reading, both are reading variable A, reading and writing variable A. Then transaction T2, that is also reading that A variable only, and then reading, writing the A variable only, then reading the A variable. So here you can see commit. So now as it is committed, so if any problem arises over here, we cannot roll back. Why? Because it's already committed. Understanding what I mean? So here as you can see there are two transactions. See, T2 read the value of A, that is returned by T1 and committed. And T1 later aborted, therefore the value read by T2 is wrong. Since T2 is committed, okay, you can see here T2 is committed. So because of that we cannot roll back. So that's why it is non-recoverable schedule. So I hope it's clear. Now let us solve some previous year questions based on the same topic, schedule. See, this is your GATE CSE 2016 question. Okay. Now if you will see this question properly, it says that consider the database schedule with two transactions T1 and T2. Okay, so S is equals to, now here they have given the schedule. So before we'll move further, we need to construct the table. So let us construct the table over here. So these are the two. See, now how to construct this table. So see here, what is the maximum number we are having? The maximum number here we are having 2. So that means there are 2 transactions. So write down T1 and T2. Now if you see what they are doing, R2 of X. That means we will perform read operation in which transaction? 2. R2 na. So here don't write R2. Here we can write only R of X. Then R1 of X. That means reading variable X. But in which transaction? 1 no, so T1. So it will be R of X in T1. And one more thing, don't write it in the same line. It should be written below like this. Okay. Next is R2 of Y. Okay. So here read operation with Y variable. Next, write operation in transaction T1. So write of X. Next, read of Y. So here read operation with Y variable. Read operation is also in transaction T1 only, right? So here you can see after read operation is also there in transaction T1, and after that write operation is there in transaction T2. Okay, then after that A1 and A2. Okay, then A1 actually here represent the abort. Okay, so then A1, that means first in transaction T1 abort. Okay, then in transaction T2 we are having the abort. Okay, so this is one table. This is the way we construct the table first of all. Okay, now see what question they have asked. Here they said that where R of Z, that denote, that what I told you, R means read operation, W means write operation. Okay, and inside the bracket whatever X, Y is there, that is nothing but known as variable. Okay, now and here A of I denotes the abort. Okay, so the question is, which one of the following statement about the above schedule is true? So first statement says that here S is non-recoverable. Okay, so I already explained to recoverable and non-recoverable. Recoverable, that means here if any problem arises, we can recover, we can roll back. Non-recoverable because if it is committed, that means it is non-recoverable. Okay, but here what they said, S is non-recoverable, but here you can see transaction T2 has performed, then transaction T1, then T2, then T1. But they have done abort or commit statement. Here commit is not there, so they have done abort at the last. Okay, so we cannot say this as a non-recoverable. Got it? Here it is not possible because there is no dirty read as well. You can see there is no dirty read operation. That's why this is recoverable. So this is recoverable. So option A is not possible. Okay. Option B says S is recoverable. That is true. That S is recoverable. But second that it is having that but has a cascading abort. So where is the cascading abort? Okay, can you see any cascading abort over? Because you can see there is no dirty read operation here as well. So you can say there is no cascading abort. So S is recoverable, that was right, but there is no cascading abort. And as there is no cascading abort, I can say option C is the correct one. Okay, now here even we'll check for option D as well. Why option D is not true? Because if you see in the image that after W1 of X, that means after W of X, before T1 commit, okay, after W of X, they have writing it, okay, after T1 commit, before T2 has also returned X. Okay, so that means it is not a strict schedule. Got it? So the correct answer for this question was option C. I hope it's clear. Next. There is one more question. This is your GATE 2015 question. Okay, let us read the question and a little bit of zoom it. See, consider the partial schedule as involving two transactions T1 and T2. Only read and write operation have been shown. The read operation on the data item P is denoted as R of P, that is R means read and W means write operation. Okay, so like I explained you the same concept over here as well. See, let us try to understand. This is your T1, T2, and these are the options. Okay. Suppose that the transaction T1 fails immediately after time instance 9. Okay. So see, this is the time instance. The time 1, they have the read operation with A. At time 2, transaction T1 is return A. At T3, transaction T2 is reading C variable. Okay. So they are telling that suppose after this 9 instance, T1 will fail after this 9 instance. So which one of the following statement is correct? Okay. Now here if you say option A, what option A is telling that T2 must be aborted and then both T1 and T2 must be restarted to ensure transaction atomicity. Okay, so first of all, here you see, if you see it properly, transaction T1 is not right. Why? Because as it says that it abort the transaction T2, as what it is telling that it is aborting the transaction T2. So see, as it aborted the transaction T2, then I can say that it will redo all the operation, undo and redo. Okay, undo means backtrack, redo means forward, right? So what will happen? It will redo it. So that means you can say that it is not guaranteed that it will be successful. Got it? So option A cannot be right. Now if you see option B says that schedule S is non-recoverable. Now what do you mean by non-recoverable? Non-recoverable, that means here we cannot recover. Right? So here if you will see, as it is non-recoverable only. Why? Because they are committed. So if any problem arises here, it cannot roll back. Okay, so that is true that this schedule is recoverable. Okay. The next is it cannot ensure atomicity. That is also true. In the first option only I said that. It is not ensuring atomicity. Okay. So as it is not ensuring atomicity, so the correct answer is option B over here. Okay. One more thing, I want you to make a note about this atomicity. You will get a confused with atomicity word. So you can make a note that, see, okay, I'll explain here as well. Here this schedule is non-recoverable. Okay. So as it is non-recoverable, that means it is also not atomic. Make a note. Here it is non-recoverable, that means it is also not atomic, since it leaves the database in an inconsistency. So here you can see this database is an inconsistent state, and because it's not maintaining its consistency. Got it? So the correct answer is option B. And even option C and D is also not right, because it's telling it ensures transition atomicity, it ensures transaction atomicity. But here we can clearly see it is not ensuring transaction atomicity. So the correct answer is option B. C and D is also not right. So this is all about the topic schedule. It's important. So sometimes they'll ask a theory question. This type of question only they'll prepare this. Okay, thank you. If you like my video, please like and subscribe my channel. Thank you. And any doubt is there, you can write it in comment. Definitely I'll reply. Thank you.